Hey coders, how's it going? Mohamedou here, back again. And throughout this lesson, we are going to be learning about name tuples. So thus far, we have learned about several different built-in types in Python, such as lists, strings, integers, and floats. But sometimes these built-in types aren't enough to solve certain kinds of problems or represent certain kinds of data. And Python actually provides solutions for this by allowing us to create our very own types, or sometimes referred to as objects. And one of the ways that we can do this is by using name tuples. So throughout this lesson, we are going to dive into name tuples and understand what it is, how it works, and how we can use it in our code. So I'll see you all in the next few videos. So what is a name tuple? Well, a name tuple is a function in Python that allows us to create our own custom types. So in other words, the namedtuple function allows us to create blueprints that describe objects. So let's think about an example in the real world. So an iPhone is an object, and an iPhone has attributes. It has a name, it has a color, it has a price, and it has a storage size, such as how many gigabytes the iPhone has. As another example, a MacBook is also an object. A MacBook has a screen size, it has CPU core, it has the weight, it has a price. A watch is also an object. A watch has the size, the price, a name. A TV is also an object. So anything that you can really think of is an object. And before these objects can actually be made and manufactured, there must exist a blueprint for these objects. Otherwise, manufacturers would have no idea how to make them. So going back to our iPhone example, in order to actually make a real iPhone, an iPhone blueprint must exist. And the iPhone blueprint will specify this is an iPhone blueprint. And the blueprint will also include all of the attributes of an iPhone, such as its name, the number of gigabytes it has, the color, the price, and even the screen size, and all other attributes that would make up an iPhone. Then we could take this blueprint and give it to a manufacturer, and then they can refer to this blueprint to create thousands of actual iPhones. The same thing also applies to a MacBook. We would first create a MacBook blueprint. We would specify all of the attributes that a MacBook has, such as the screen size, the number of RAM, the number of CPU, the price, the color, and all other attributes that a MacBook has. Then we could take this MacBook blueprint, give it to a manufacturer, and the manufacturer can refer to this blueprint to create real MacBooks. We would apply the same logic to any other kind of blueprint, whether it's a TV or a watch or a blender or a microwave. These are all objects, but first we would need to have a blueprint that describes what it is that we're making and the different attributes that it has. Now, this same concept also applies with name tuples. First, we would use the name tuple function to create a blueprint that describes an object. So, for example, we could use the name tuple function to create our own iPhone type or our own iPhone blueprint. And then we could also specify all of the attributes that an iPhone has. Then we can use this blueprint to create actual iPhone objects. We could also use the namedtuple function to create a MacBook blueprint and also specify all of the attributes that a MacBook has. We could also use the namedtuple function to create a TV blueprint and then specify all of the attributes that a TV has. Then, using this blueprint, we could create actual TVs. So let's head over to the next video so we can see how we can use the nametuple function to create our own custom types. Or in other words, how we can create blueprints. So I'll see you all there. Let's see how we can create blueprints using the nametuple function. So before we can start using the nametuple function in our code, we need to make sure that we include a special line at the top of our program, and that's from collections, import nametuple. And you don't need to understand why we do this or why or how this works. You just need to remember to include this statement on the first line of your code. So after we do that, we can start using the nametuple function. So let's go ahead and create an iPhone blueprint. So in order to do that, first we'll start off by calling the nametuple function. And that looks like the following: nametuple. So now we can go ahead and as the first argument to the nametuple function, we can specify what is the name of this blueprint. And we do this by creating a string. So we'll go ahead and say that this is an iPhone blueprint. Then we'll have a comma, and then we'll have a list that contains all of the attributes of an iPhone. And these can be any kind of attributes. It's up to you to decide what attributes you want your blueprint to have. So in our case, I'll say that this iPhone blueprint has a name, has a size in gigabytes, and this should also be a string. Let's say it also has a color, and let's say it also has a price. So here we've created a blueprint using the nametuple function. Our nametuple is called iPhone, and here we have a list of all the attributes that an iPhone has. And we've stated that an iPhone has a name, a size in gigabytes, a color, and a price. And we can have as many or as little attributes as we'd like. And we can actually store what this nametuple creates into a variable. And we'll call this variable iPhone. So the nametuple function returns the blueprint, or it returns the type that we have just created. So in this case, it has returned a new iPhone type. So let's go ahead and create another type or another blueprint. So we'll use the nametuple function, and this time we'll create a MacBook blueprint. And the name of our blueprint will be MacBook. We'll have a comma, and then we'll create a list that will contain all of the attributes of a MacBook. So let's say a MacBook has a name. It also has a screen size. We'll say that it also has CPU size. And the last attribute will be the weight. So here we have a MacBook blueprint. That's the name. And here we have a list of all of the attributes that a MacBook has. And it has a name, a screen size, a CPU size, and a weight. So now we can go ahead and save the result of what this nametuple function will return into a variable. And we can call this variable MacBook. Next, let's create another blueprint. And this blueprint will represent a person. So we'll call the nametuple function, and we'll name this blueprint person. We'll have a comma, and we'll create a list of all the attributes that a person has. And we'll say that a person has a name, an age, a date of birth, and we can say the city that they're from. And let's go ahead and save this new type, which is person, into a variable, and we'll call this variable person. So now we've created a person blueprint that has 4 attributes: a name, an age, a date of birth, and a city. So this is going to create this new type, and we're going to save this type into a variable called person. So we've created 3 different types. And as you can see, these are 3 different blueprints. And each blueprint specifies the name of the blueprint and all of the attributes that it has. So one thing that's important to note when you're creating attributes for a blueprint is that attribute names can consist of uppercase letters, lowercase letters, digits, and underscores. They must start with a letter or an underscore, but cannot start with a digit. In addition, attribute names cannot contain punctuation or spaces. Another thing to keep in mind is that when you're creating blueprints and specifying their attributes, these attributes will always be represented as a list of strings. As we can see here, for our iPhone blueprint, we have a list of strings for the attributes. For the MacBook blueprint, we have a list of strings for the attributes, and the same for a person. So anytime you're using the namedtuple function to create a blueprint, the attributes will always be represented as a list of strings. So here we've used the namedtuple function to create 3 different blueprints, and we've saved these new types into corresponding variables. We have iPhone, MacBook, and person. So we have 3 new types. And now we can go ahead and use these types to create actual objects. So let's go ahead to the next video and we'll see this in action. So I'll see you all there. So let's see how we can create actual objects using our blueprints. So let's start off with our iPhone blueprint. We see here that we created an iPhone blueprint and we stored the blueprint, or we stored the type, into a variable called iPhone. So let's go ahead and create some real iPhones. So we'll start off with the variable iPhone, which is here. And we'll go ahead and have an open and close parentheses. So it's almost like we're calling this like a function. And inside the function, we want to specify all of the attributes that an iPhone has. And we do want to make sure that we specify the attributes in the same order that we see in the blueprint. So let's go ahead and come up with a name. And we can choose any name. So I'll choose 12. So this will be an iPhone 12. Next, we have to specify size in gigabytes. So we can actually choose any kind of type to represent size in gigabytes. For example, we could choose a string, and I could say 128 gigabytes. Or if I wanted to, I could just choose an int, 128. Or if I wanted to, I could also choose a float. So I'll go ahead and keep this as an int. And although when we created the blueprint, we specified each attribute as a string, when it comes time to actually create objects, we can choose any kind of type for each attribute. So as we can see, for name, I chose a string. For size in gigabytes, I chose an int. So let's go ahead and create a color, since we know that's the next attribute that an iPhone has. So I'll choose green. And for price, I'll choose a float. And let's say the price is $12.99.99. And so here we have our very first iPhone object. And we can actually store this into a variable. And we'll name this variable iPhone 12. So let's go ahead and create another iPhone object. Similar to before, we'll use this iPhone variable here. Next, we'll have an open and close parentheses. And now we can start listing all of the attributes that an iPhone has. And this time we can actually include the name of the attributes. So we can say the name attribute is equal to, and let's name this iPhone 13. Next, we can say the size in gigabytes is equal to, and let's say the size is 256. Next, let's say that the price attribute is equal to $14.99.99. And lastly, let's say that the color attribute is equal to blue. And we can also store this object into a variable. And we'll name this variable iPhone 13. So these are the 2 ways that we can create actual objects. The first way, we don't specify the name of the attributes when we list all the attributes that an iPhone has. Note that if you do decide to create an object in this way, then the order in which you list the attributes does matter, and the order must match the same order that we see the attributes listed when we created our blueprint. And as you can see, first we have the name, then we have the size in gigabytes, then we have the color, and then we have the price. And that matches the same order that we see in the blueprint. So the second way that we can create objects is by specifying the name of each attribute when we're listing out all of the attributes that an iPhone has. So here we can see, first we have the name attribute, and we set it equal to 13. Next we have the size in gigabytes attribute, and we set it equal to 256. Next we have the price attribute, and we set it equal to 1499.99. Lastly, we have the color attribute, and we set it equal to blue. And you'll notice that all of the attributes are spelled the exact same way as we see them in the blueprint. So you do need to make sure that you spell them the exact same way, and casing does matter. Also, if you decide to create objects in this way, then the order in which you specify the attributes does not matter. So for example, we can see in the blueprint, price is listed as the fourth attribute. But you can see here that when we created our iPhone object, we specified price as the third attribute. So you can create objects in either of these two ways. If you decide to create an object the first way by not including the name of the attributes, then just keep in mind that the order in which you specify the attributes does matter. Now, if you decide to create an object the second way by including the name of the attributes, then this can make your code more readable and make it easier to understand the values that are being assigned to each attribute. So next, let's go ahead and print out each iPhone that we've created. So first we'll print out the iPhone 12. So let's go ahead and print out our iPhone 13. Let's go ahead and run this. And as you can see, we get both iPhones printed. Now, one thing to keep in mind is that regardless of how you decide to create your objects, whether that's by omitting the name of the attributes or by including the name of the attributes, the default way that objects are printed will include the name of the attributes. So we can see that in both cases here for the iPhone 12 and the 13. So next, let's see how we can create some MacBook objects. So let's go ahead and start off with the MacBook variable. Then we'll have an open and close parentheses, and now we can start listing all of the attributes that a MacBook has. So we'll start off with the name attribute, and we'll name this Air. Next, we have the screen size attribute, and we'll set this to a string that says 13-inch. Next, we have the CPU size, and we'll use an int and use the number 8. Next, we have the weight attribute, and we'll use a float, and we'll do 2.01. Let's go ahead and save this to a variable. We'll name this variable Air. Let's go ahead and create another MacBook. And this time, we're going to include the name of the attributes. So we'll start off with name, and we'll set this equal to Pro. Next, we'll have the weight attribute, and we'll set this equal to 3.01. Next, let's set the CPU size attribute to be 4. And lastly, let's set the screen size attribute to be equal to 15-inch. Next, let's go ahead and assign this to a variable, and we'll name this variable Pro. Now let's go ahead and print out both of these objects. So we'll print out Air, and then we'll print out Pro. Now let's go ahead and run this. And as you can see, we have both of our MacBooks printed. We have Air and the Pro. So next, let's see some examples creating person objects. So first we'll start off with the person variable. Then we have an open and close parentheses. And now we can start listing out all of the attributes that a person has. So let's start off with the name attribute. We'll set the name to Prince. Next, we have the age attribute, and we'll set that to 25. Next, we have the date of birth, So we'll set that to a string, and we'll say 10, 20, 90. Next, we have the city attribute, and we'll set this to New York. Let's go ahead and assign this to a variable, and we'll name the variable Prince. Next, let's create another person object, and this time we'll include the name of the attributes as we list out all of the attributes that a person has. So we'll start off with date of birth. We'll set this to a string, and we'll say 12, 28, 93. Next, we'll do the age attribute, and we'll set this equal to 28. Next, we will do the city attribute, and we'll set this equal to Los Angeles. And lastly, we have the name attribute, and we'll set this equal to Malcolm. So let's go ahead and assign this to a variable. We'll name this variable Malcolm. Now let's go ahead and print out both of these person objects. So first we'll print Prince, and then we'll print Malcolm. So let's go ahead and run this. And as we can see, we get both person objects that we created. And that basically wraps up how we can create our own custom objects in Python. So just like in the real world, if you want to create an object, you must refer to its blueprint. For example, the company Apple sells many different kinds of objects. They sell iPhones and MacBooks. So Apple would have a blueprint specifically for iPhones. And in that blueprint, it would specify all of the attributes that an iPhone has. Similarly, they would have a blueprint specifically for MacBooks. And in that blueprint, it would specify all of the attributes that a MacBook has. Then Apple could take both of these blueprints and give them to manufacturing companies who can then refer to these blueprints to create real iPhones and real MacBooks. Here in our code, we did something very similar. We created an iPhone blueprint and we specified all of the attributes that an iPhone has. Then we refer to that blueprint to create two iPhone objects. Similarly, we created a MacBook blueprint and then we specified all of the attributes that a MacBook has. Then we refer to that blueprint to create two MacBook objects. And lastly, we created a person blueprint and then we specified all of the attributes that a person has. Then we refer to that blueprint to create two person objects. Next, we're going to learn how we can access individual attributes from our objects. Let's learn how we can access individual attributes from our objects. And we can actually do this in one of two ways. The first way is using indexing with the position of the attribute. So if we look at our iPhone blueprint, we see that we have a list that contains 4 attributes. And we can actually use the index of each attribute to access it individually. So for example, the name attribute is located at index 0. Size in gigabytes is located at index 1. Color is located at index 2. And price is located at index 3. And similarly, we could also use negative indexing. So price would also be located at index -1. Color would be located at index -2. Size in gigabytes would be located at index -3. And name would be located at index -4. So using our iPhone objects that we've created, let's go ahead and access individual attributes. So we'll start off with our iPhone 12. So if we wanted to access the name attribute using indexing, we would use index 0. And let's go ahead and print this out. And let's go ahead and run this. And as you can see, we get 12. And that's the name of our iPhone object. Next, let's go ahead and access another attribute. So this time we'll go ahead and access the color attribute. And we know that color is located at index 2. So let's go ahead and add that. Let's also add a string so we can see that in the output. And let's print this out. And as you can see, we get green. Next, let's access some attributes from our iPhone 13. So let's access the price attribute. And we know that that is the last attribute, so we can use -1. Let's go ahead and print this. And let's run this. And as you can see, we have the price, $14.99.99. Next, let's print out the size in gigabytes attribute from the iPhone 13. So let's go ahead and create that expression. And we know that size in gigabytes is located at index 1. So let's go ahead and print this out. Next, let's run our code. And as we can see, we get 256. So next, let's create another example. And this time, let's access the price attribute from iPhone 12. And let's also access the price attribute from iPhone 13. And let's combine them and let's print out the result of that. So first, let's access the price attribute from iPhone 12. And we know that the price attribute is the last attribute. So we can use the index -1. Next, we want to combine this with the price attribute of our iPhone 13. And we know that that is also at index -1. Let's go ahead and print this out. Next, let's go ahead and run this. Oh, looks like I forgot a missing bracket. So let's go ahead and add that. Let's go ahead and run this again. And as you can see, we get 2799.98. So we can even use indexing to access individual attributes from an object and then create expressions. As we've seen here, we use indexing to access the price attribute from the iPhone 12 and the iPhone 13 and then combine them by using the addition operator. And this is how we can access individual attributes from an object. So let's go ahead and leave a comment of this. And we'll say using indexing with the position of the attribute. And now the second way that we can access individual attributes from an object is using dot notation. So leave a comment and say using dot notation. And let's see this in action. So let's say we wanted to access the name attribute from our iPhone 12. So let's go ahead and we'll first start off with the iPhone 12 variable, and then we'll have a dot, and then afterwards we can specify the name of the attribute. And in this case, it's name. So let's go ahead and print this out. Next, let's run this. And you can see, we see the name of our iPhone, which is 12. Next, let's go ahead and access the color attribute from our iPhone 12. So similar to before, we'll start off with the iPhone 12 variable. We'll have a dot, and then we'll specify the name of the attribute that we want to access. In this case, it's color. So let's go ahead and put this in a print statement. And then let's run our code. And as you can see, we see green. Next, let's go ahead and access some attributes from our iPhone 13. So let's access the price attribute. So we'll start off with our iPhone 13. We'll do dot, and then we'll specify price. So let's go ahead and wrap this in a print statement. And let's run our code. And as you can see, we get 1499.99. So similar to before, let's access the price attribute from our iPhone 12 and from our iPhone 13. Let's add them together and let's print out the result. So let's do iPhone 12 dot price plus iPhone 13 dot price. Let's go ahead and print out this expression. Next, let's go ahead and run this. And as you can see, we get 2799.98. So next, let's go ahead and access individual attributes from our MacBook objects. So let's go ahead and start off with our Air object. And let's access the name attribute using indexing. And we know that the name attribute is located at index 0. So let's go ahead and put this in a print statement. And let's run our code. And we can see we get error. Next, using dot notation, let's access the weight attribute from our air object. So we'll do air dot weight. Let's go ahead and print this out. Let's run this. And as you can see, we get 2.01. Next, let's access some attributes from our Pro object. So using dot notation, let's access the screen size attribute. So we'll do Pro dot screen size. Let's go ahead and run this. Let's wrap this in a print statement. And here we see 15-inch. So if you want to access individual attributes from an object, you can do that using indexing or dot notation. Both ways give you the same result, but using dot notation is more readable and less error prone than using indexing. This is because when you use dot notation, you don't have to remember the order of the attributes, and it's less likely you'll access the wrong attribute by mistake. In addition, when you use dot notation, it's very clear which attribute you're intending to access. So this essentially concludes how to access individual attributes from an object. Let's learn how to update an object's attributes. So we know that using dot notation, we can access individual attributes of an object. For example, if we wanted to access the name attribute from iPhone 12, we will do this the following way. We'd have iPhone 12 dot name. So you might be tempted to try and reassign this attribute to a new name. For example, if I wanted to reassign the name attribute to 12 Pro, intuitively, you may think it would look something like this. Let's go ahead and run this. So this actually results in an attribute error, and we see the error message says can't set attribute. And this happens because nametuples in Python are immutable. And that's just a fancy way of saying that nametuples cannot be changed after they have been created. So all the objects that we have created cannot be updated after you have created them. So let's go ahead and leave a comment describing this. So we cannot do this because nametuples are immutable. In other words, they can't be updated after they have been created. So if we wanted to update the value or update an attribute of this iPhone 12 object, then we would have to recreate a new iPhone object. So for example, if I knew that I wanted to update the name attribute of iPhone 12, I could go ahead and assign this iPhone 12 variable to a new object. So we can go ahead and paste this, and then we can go ahead and update the name. But this can be very error prone because copying and pasting and coding is typically never recommended. So this here isn't a good idea. So let's write a comma here and say this is a bad way to update an object. Copying and pasting is never recommended. So in Python, there's actually a built-in function that we can use to mimic what we just did. And if you recall, we copied over the original iPhone 12 that we created, we pasted it here, and then we just updated the name. And then we reassigned this object to the iPhone 12 variable. So we can actually use a function that's called underscore replace. So the way it works is first you'll start off with the object, and in this case, it's iPhone 12. Then we will do a dot, then we will do an underscore, and then we write out replace. And then we have a pair of parentheses, and inside these parentheses, we can specify one or more attributes that we'd like to update. And in our case, we only want to update the name attribute. So we'll go ahead and put name, and then we can go ahead and assign the name attribute to be equal to anything that we like. And in our case, we want the name attribute to now be equal to 12 Pro. So the replace function works by creating and returning a brand new object. And it does this by first copying over all of the attributes from the iPhone 12, but replacing the name attribute with 12 Pro. And if we recall earlier, first I copied over this iPhone 12, and then I pasted it over here. And then I went ahead and updated the name manually to 12 Pro. So the replace function does the exact same thing. First, it copies over all of the attributes from iPhone 12, but it replaces the name attribute to be 12 Pro. And then it returns a brand new object. So we can actually capture this object and store it back into the iPhone 12 variable. So let's go ahead and actually comment this out. And let's also comment this out too, so we don't get that attribute error again in the output. And let's go ahead and print out iPhone 12. Let's go ahead and run this. And as you can see, the name is now 12 Pro. And let's actually print it out here as well, so we can see the difference. So let's run this again. And as you can see, the first time I printed it, the name is 12. And the second time I printed it, the name is 12 Pro. Now, if we wanted to, we could actually create a new variable and assign it to what the replace function returns. So let's go ahead and rename this variable and say new iPhone 12. And let's also update this to be new iPhone 12. Now let's go ahead and run this again. And here we see iPhone 12. And the second time we see new iPhone 12. So doing it this way allows you to keep the original iPhone that you first created, and then it allows us to get the new iPhone 12 with the changes made. So that way we're not overwriting or reassigning this original iPhone 12 variable. So we still have access to both. Now let's go over another example. And this time, let's say we want to take iPhone 13 and we want to update the name attribute and the size in gigabytes attribute. So let's use the replace function for this. So we'll start off with iPhone 13. And then we'll do dot underscore replace. And let's go ahead and update the name attribute, and we'll set it to 13 Pro. And then we also want to update the size in gigabytes attribute. So we can do this by adding a comma and then adding the size in gigabytes attribute. Let's go ahead and set this to be 128. We can go ahead and reassign the iPhone 13 variable to be equal to the new object that the replace function is going to return. So let's go ahead and print out iPhone 13. And we should expect to see the name and the size in gigabytes updated. So let's go ahead and run this. And as you can see, now we have 13 Pro, and the size of gigabytes is now 128. The replace function should always be used when you want to update the attributes of an object. It's a great utility and beneficial for a few reasons. One of which is you don't have to write out all of the attributes that you want to remain the same. This means that you don't need to manually specify all of the attributes, for example, by copying and pasting. So if you recall from earlier, when we wanted to update the name attribute of the iPhone 12, we copied it over and pasted it just so we could manually update the name. So in using the replace function, we don't have to do that. This can be very error prone because you may copy over the wrong object, resulting in a different output. Another reason the replace function is useful is it allows you to specify multiple attributes that you want updated in a clear and readable way. As we see here, when we updated the iPhone 13, we were able to update the name attribute and the size in gigabytes attribute at the same time. Another way that the replace function is useful is it allows you to keep the original object. So recall when we were updating the name attribute for our iPhone 12. We updated the name attribute to be 12 Pro, and we know that the replace function is going to return a new object. And instead of reassigning the iPhone 12 variable to be equal to this new object, we decided to assign this new object to a new variable called new iPhone 12. So that allows us to keep our existing iPhone 12 while now we have a new iPhone 12 that has the same attributes as the iPhone 12, except that the name attribute is now 12 Pro. So these are just a few of the ways that the replace function is useful. And whenever you want to update the attribute of an object, always opt for using the replace function. So that essentially wraps up how to update an object's attributes. So let's go over some examples of using our objects. So first I'm going to start off by creating a list of iPhones. So I'll create a variable called list of iPhones, and I'll assign it to a list. And let's go ahead and add iPhone 12 and iPhone 13 to our list. And if we wanted to, we could also create a list of iPhones in the following way. So we could just have the objects directly in the list. We don't have to assign them to a variable first and then put the variables in the list. We also could do this as well. So I'll go ahead and comment this out, and I'll leave a comment at the top. And I'll say, we can also create a list of objects like this too. So now that we have our list of iPhones, let's go ahead and start using indexing so we can access individual items from the list. So first, let's access the iPhone 12. And we know that the iPhone 12 is located at index 0. So we'll go ahead and write out list of iPhones, and we'll access the item at index 0. So this is really just iPhone 12. And we know that we can do this, right? We can do iPhone 12.name to access the name attribute. So whatever we can do with the iPhone 12 variable, we can also do with this. So we could do list of iPhones at index 0 dot name. Oh, I forgot the dot. Let me add that. This is perfectly valid because we can also do iPhone 12 dot name. And we know that the item at index 0 is iPhone 12. So let's go ahead and print both of these out. Let's go ahead and run our code. And we see 12 and 12. And let's actually add some strings so we can see this in the output where each output is coming from. So let's also update this as well. And let's run this again. So as you can see, when we do list of iPhones at index 0 dot name, we get 12. And when we do iPhone 12 dot name, we also get 12. So these are just two different ways that we can access the name attribute from iPhone 12. Similarly, if we wanted to, we could store what we get back from the index into a variable. So we could say a iPhone 12, And then we could say list of iPhones at index 0. And this will give us the iPhone 12. And then we could also print out a iPhone 12 dot color. Let's go ahead and run this. And we get green. Next, we could do iPhone 13. So let's go ahead and access iPhone 13 from the list of iPhones using indexing. So we would do list of iPhones at the -1 index, since we know that iPhone 13 is the last element in the list. And since we know that this is the iPhone 13, we can use dot notation to access different attributes. So let's write a comment and we'll say, this is iPhone 13. So we can do dot price. Let's go ahead and write another expression. So we can also do dot name. So let's go ahead and print this out. And let's also print this out as well. Let's go ahead and run this. And as you can see, we get $14.99, and we also get 13, which is the name. And let's also include a string in the beginning, just so we can see that in the output. Let's include that here as well. And let's go ahead and run this again. So here we see list of iPhones at the -1 index dot price gives us $14.99.99, and list of iPhones at the -1 index dot name gives us 13. Let's go over another example. And let's go ahead and create an expression checking whether the price of iPhone 13 is less than the price of iPhone 12. So let's go ahead and do list of iPhones at the -1 index, since we know that this is the iPhone 13. And let's do dot notation and access the price. We'll have the less than operator. And then we could do list of iPhones at index 0. And we know that this is the iPhone 12. So now we can do dot price. And this expression will result in either true or false. So let's go ahead and print this out. And let's run our code. And we get false. So this means that the iPhone 13 price is not less than the iPhone 12 price. And we can see that this is true. Let's do another example. And this time we'll create a string that says, I want to buy the iPhone 12 and the iPhone 13. So let's go ahead and jot down what the string should look like. I want to buy the iPhone 12 and 13. So let's go ahead and create the string. So first we'll start off with I want to buy the iPhone. Now we need to include 12 and 13. So we can have a plus sign, which is the addition operator, and then we can add the 12. And to get to 12, we know that we need to access the iPhone 12 object. Then we can use dot notation to get the name attribute. So we can do this in one of two ways. We could use list of iPhones at the 0th index and do dot name. Alternatively, we could also just do iPhone 12 dot name. Let's go ahead and use indexing and use the list of iPhones. Next, we'll have a plus. And we know that we want a space between the 12 and the word and. So add a space. And then we'll add the word and. And then we'll add another space because we know we want a space after the word and before 13. So we'll have another plus. And then we'll go ahead and add the 13. And we know that we can get that from the iPhone 13. So we'll go ahead and do list of iPhones at the -1 index, and we'll do dot name. So let's go ahead and print this out. And let's go ahead and run this. So as you can see, we get I want to buy the iPhone 12 and 13. And these are just some of the many different kinds of expressions that we can create using our objects. In general, name tuples are very powerful, and there are many different things that we can do with them.